Today we are going to work on the lead code problem, find the minimum element in a rotated sorted array. So this problem is categorized as a common Google coding interview question, and you can expect this question for a SD1 interview. And the reason this question is so common is essentially it helps us to filter out candidates who are not very good at programming. So an array is a very basic data structure, doesn't require too much explanation. So this is kind of a logic problem where here's an array, and although it's in sorted order, it has been rotated for a certain number of times. So here, for example, the minimum element is somewhere in the middle of the array. Since it was rotated 4 times, the first 4 elements are kind of like elements that should have been the end of the array, but they have been moved to the front. So here's another example. Here they've been rotated 7 times, but that means it's already sorted order. So usually candidates who try solving this will try to do it in a linear fashion where they'll create a for loop, they'll traverse down the array, and they'll see which element is the minimum and return it. And the interviewer will immediately say, I'm looking for a logN solution. So if the candidate's unable to solve this problem, I think it's an immediate reject. So it doesn't even matter. It doesn't even go to the, actually I would say, to the other interview rounds. So yeah, to solve it, the way to solve it is kind of using binary search, but it's something like in addition to it. So in binary search, we try to find an element and we say that, hey, this is the element. Since in a sorted order, we can keep filtering down the array into half. But here we need to do something similar. But here, since it's rotated, we need to add a special case to it. So yeah, I'll explain. So first, for creating binary search, we'll create 2 pointers, one to point to the left and the right. So int left equal to 0. Right is equal to nums.leg. So here I'll create using a while loop. So the reason I'm checking in this condition is, imagine we are given an array of size 1. We don't need to really process it. We can just say return. So just returns the element inside the array. But now imagine the left and right pointer are pointing to 2 different elements. The first thing we can do is we can check if the array is already in the sorted order. So here's an example. Since it's already sorted, we just say if nums left we just return the number. So here no processing is required. So now imagine it's not in sorted order. So here's where we start to do the processing. So similar to binary search, we find the midpoint. So if lesser than equal to nums mid. So this is a case. So imagine we have reached the element, say for example, here we reached the element 7 and the element in the left is 4. Since here 4 to 7 are already in a sorted order, we know the minimum element has to be somewhere in the right. So we say left is equal to mid plus 1. Else, imagine we reach the point 1 or 0 and it's it's smaller than 4. So we know that either the element itself could be the minimum element or some element to the left. So here we say right equal to mid. And yeah, we keep processing it and we keep dividing the array into halves until finally we find the minimum element. So yeah, let me try running the solution. Okay, all the 3 use cases are passed. Try submitting it. So yeah, the solution has been accepted. So here we can see that the time complexity of this solution is going to be logN, since here we are using the midpoint and we keep subdividing the array into that. And as for the space complexity, everything is being done in place, so it'll be O of 1. So it'll be in constant space complexity.